Aloha and welcome to our video on Igneous Rocks. In this video we are going to compare and contrast intrusive and extrusive igneous rocks. We'll talk a little bit about texture and discuss how the rate of cooling affects it, and then finally we'll show you how we classify igneous rocks based on their composition. Okay, when we're talking about igneous rocks, we have two primary categories. We have intrusive and extrusive. Intrusive igneous rock formation is going to be where it's inside the earth. Okay, so we'll see that we have magma down here, and that magma will cool off over time, and that's what will form this intrusive rocks. Extrusive is when we break the surface and we have lava, and it's going to cool on the surface. So it kind of gives us an idea. Intrusive is going to be from magma inside the earth. Extrusive is going to be outside of the earth. It's going to come from lava and primarily through volcanic activities and things of that nature. All right, now that we know where the igneous rocks are formed, whether they're inside as intrusive or on the surface as extrusive, we can now take a look at texture, and we can determine from it, it kind of gives us a way of categorizing it a little better. We can have a glassy texture, which is shiny, it looks like glass. You're not going to see any crystals at all. It's just going to be a nice, clean looking glass-like piece of rock. We can have some that's going to be fine-grained, where you can have microscopic little crystals. Okay? Or it can be coarse-grained, where you'll have these larger interlocking crystals, and you can see those with the naked eye. And then we can have this porphyritic texture. The porphyritic texture is defined as rocky roadish kind of, and that's going to mean that it's going to have a little bit of these coarse grains in here that you can see, but you're also going to see a bunch of little smaller crystals as well. So it's kind of like a mixture between the fine and the coarse grained. Now, these textures can be explained kind of how we have it cooling off of this molten material to form the igneous rock. If we start first with our extrusive, and we realize this, if we take this rock and we throw it out into the atmosphere, dump it into water, or set it down, it's going to cool a lot faster. So when you have an extrusive, it's going to be rapid cooling. So if it's rapid cooling, what that means is that there's not enough time for large crystals to form. So that's how we end up with our obsidian here that has no real crystals, or your basalt, which is going to have these tiny little microscopic crystals. Okay, so there's tiny little crystals in there, but it's because it cooled off so much faster, and that's what's going to give us our smaller crystal textures. Conversely, if we have our magma here trapped in the earth is going to work like an insulator, and it's going to cause this to cool much slower. Because it cools much slower, we can look over here and we can see that we have these larger crystals in here that we can actually see them out. They're individual different crystals. So this slow cooling will allow for larger crystals to form. So that's kind of how we can determine, not only based on where it forms, but the size of the crystals is how long it took to cool. Slow, long cooling is going to have larger crystals. If it's rapidly cooled, you're not going to have time for that crystal growth to happen. So when we talk about the composition of magma, we're going to talk about three different classes. The first one is going to be this granitic over here. The granitic are going to be formed from these lighter colored elements, these lighter colored minerals, and it's only going to be about 10% dark silicates. So your granitic ones are going to be lighter in coloration. Now the opposite of that are going to be these basaltic ones over here, and these are going to be the darker colored minerals, and there's mostly dark silicates. So we're talking about like 80-90% dark silicates as opposed to only 10% of the granitic. And then we have the third term here, this andesitic, which is going to be in between these two. So we can have our light colored ones that will form out, and then we can have our darker basalt rocks that are going to be a lot darker, and then in between we just lump these together and call them andesitic. So when we talk about composition, that's what we're looking at. How much of it is going to be these dark silicates, and that's how we name them. So in summary, when we're talking about classifying igneous rocks, we want to start with where they were formed, and that'll determine whether it's intrusive or extrusive. But then we can look over here and we can find the texture, and then we can also find its composition. Now its composition will tell us what we have. Remember, we talked about the granitic being lighter in colors, the basaltic being darker, and the andesitic kind of in the middle. And we can see the dominant minerals that are going to form here. Then we can talk about how it cooled, how it was this cooling process, and that'll give us an idea of the texture. And then down here we can see this dark minerals, and we can see about what we're talking about. So you remember we said granitic is going to be lower in minerals from about 25% to 0, Basaltic's going to be about 45 to 85%. Okay, and then we can go from there. We do have this ultramafic, which is kind of rare, but you can see it down here. They're kind of uncommon to find it in glassy and porphyritic textures. But I wanted you to see that this is how we'll classify our igneous rocks. Okay, well that does it for the video. All of this will be explained a little bit more in detail through the lessons. As always, good luck on the lessons, and we'll see you in the next video.